And real quick, let's talk about what it even means for two, because these are universal statements, right? Like, what does it mean? What does it mean for I use different letters here. What are some good capital letters out there? I'll do A. Like, what does this statement right here even mean? Or maybe better yet, I wish this wasn't blurred. Better yet, because this is a little confusing. Let's do a real one. So this is true, what I'm going to write down here. Yeah, so what's this equivalence mean here? So maybe I'll start with this. Like, remember that, like, if we say, we got chat, we got an incoming message. That is the double negative law. What I'm asking is confusing. Let me put it this way. When we say that, like, P and, if we say not P and Q is equivalent to not P or not Q, what we're saying there is that for any statements P and Q, this is true. For any statements P and Q, when you evaluate the left side and evaluate the right side, they'll have the same truth values, right? Right here, we have a third layer. We have a third layer of domains and predicates. So really what we're saying here, or maybe we could do it exactly the same. What if I say, I'll say this. There's either negation of this whole thing, that's going to be equivalent to not A of X or not B of X. So what this is saying is, for any predicates A and B with domain D, A of X is equivalent to B of X for all X. All right, no, I'm sorry. Actually, sorry. What this is saying is that for any predicates A and B with domain D, will be true whenever for all X and D and vice versa. The point I'm trying to bring up here, I didn't even plan this. I just thought it'd be interesting to talk about. The point I'm trying to bring up here is that if we're saying that two expressions are equivalent, we're just saying that for any possible, like P and Q, both sides are going to have the same truth value. What we're saying here is that for any possible predicates any possible domains, right, these statements will always evaluate, these statements will evaluate to the same thing. That's what it means for them to be equivalent. It just means for all possible predicates you choose here and all possible domains, these statements will give the same truth value. They might be true, they might be false, but they'll be the same. That was very long-winded. Does that make sense? I think there's a very long-winded way of saying what I hope is obvious. Okay, does not make sense, but so by common law, I hope that makes sense. Yeah, so the point is, what I'm trying to say is, let's just go back to here, right? We're saying that the original conditional is equivalent to the contrapositive, and the inverse is equivalent to the converse. All we're saying there is that this works for any domain we pick. For any possible domains we pick, and any predicates we pick, right? This will be equivalent to this, and this will be equivalent to this. Meaning, like, if P of X implies Q of X is true, because remember, this is a statement, it has a truth value. Either P of X does imply Q of X to everything in the domain, or it doesn't. Then not Q of X implies P of X is true. And it also works the other way. If you know that not Q of X implies P of X is true, then P of X implies Q of X is true. If you know P of X implies Q of X is false, then you know not Q of X implies not P of X. That's supposed to be not P of X this whole time, is also false. That's what it means to be equivalent. For any domain, for anything you pick, this is totally general. It works in all cases. That's what it means to be equivalent. Like saying these are equivalent, it has to mean it works for all cases, not just some particular cases. Because, right? So equivalent means they give the same truth value in all cases. That's what I'm trying to say there. All right. Well, why is that important? Like, why am I stressing they're equivalent in all cases so bad? Does anyone have any idea, or am I just losing my mind?
I actually have a question.
Maybe stop.
So you said for all the domain, if they're they should have the same truth values if they're equivalent. So
Yeah.
if they had different domains, since they're proven to be equivalent, would they still like retain the same truth value?
Well, so the thing is here, like P of X and Q of X are all defined on, like P of X and Q of X, like remember we have this double arrow that means they have a shared domain, so they're the same domain. And but anyway, so there's kind of one domain. So if we look at the blues, right? There's
Yeah,
a domain happening here, and so it doesn't really make sense to have multiple domains. You know what I mean? Like the domain of this is gonna be the same as the domain of this.
got you.
Yeah, yeah, because they're the same. Because they're the same predicates being used. Now, good question though. For example, if I say that for all x in domain 1, P of X implies Q of X, does that mean that equivalent to for all x in domain 2, P of X implies Q of X? Remember, we make up what the domain is. We'd be talking about different things. So for example, if I were to say for all x in Virginians, so people that live in Virginia, x, actually no, let's do this. For all x in the natural numbers, right? If X is positive, then, or I'll say for all X in the real numbers, if X is positive, then the square root of X exists. Versus, wait, this is a bad example. I'm sorry to stop. I was not prepared for this. Let me think. For example, so I'm saying if there's two different domains, we don't necessarily know if they're equivalent because we're kind of talking about two different things. So whenever we say two statements are equivalent, so we're saying that these two universal statements are equivalent, we're saying that when they have the same domains, right, both of these universal statements are the same truth values, but the domains have to be the same. And so I'm trying to think of a good example. If we say for all X in for all X and here we go. For all X in VT students, I'm taking an example of the homework now. X here's let's go implies that X says, what does X say?
Hokies.
There we go. Hokies. Right? So this is theoretically, oh, you guys can see that. This is theoretically a true statement. We're saying for all X VT students, if X here's let's go, X will then say Hokies, right? But then let's look at for all X in college students, right? We don't know that if X here is let's go, and they'll say Hokies, right? They probably won't, right? For any general college student, right? Especially if they're like a UVA student or something like that. We don't have to talk about them. But the point is, so that means that the contrapositive, which would be X does not say Hokies, does not necessarily mean X does not hear let's go. The point is here, this is the contrapositive of this, but you're on a different domain, so you can't say they're equivalent because you're just talking about different things. Does that make sense?
Yeah.
Yeah. So saying two statements are equivalent means that when they have the same domain, right, these for all statements will always give the same truth values. Okay. Okay. I see this is confusing now. But anyway, means they give the same truth values, means that when they have the same domains, they will give the same truth value always. So they have the same domains, but once they have the same domains, they will always have the same truth values. That's what it means to be equivalent. If you're not equivalent, that just means you have to find one example of a domain or these predicates where they don't give the same truth value. Okay, that's what I'm trying to say.